So the other speakers were doing a bit of a quick bio, and apart from what you just heard, so I've been with Accenture for about 11 years now, and in that time, I have been focused on unique identity services, and that's enabled through biometrics. So the topic today is biometrics are cool again, or I was calling it making life easier and more secure. So I think a lot of us, through whatever channels, are getting familiar with some of the biometric modalities, as they're called. And the biometrics are basically physiological or behavioral characteristics of, in this case, of humans, but biometrics are used to identify animals as well. And you could see some of the more popular ones like finger, iris, face, and this is 3D face and infrared face. Ear characteristics are used. In some places, DNA, of course. This is a palm vein depiction of a Fujitsu palm vein scanner. Signature. And signature is kind of interesting. It's still used in financial services applications, and it's not just the black and white or blue and white image of a signature, but it's the physiological. It's how fast do you sign, how much pressure. So those characteristics, speed and pressure, are part of that behavioral. And walking is your gait recognition. And that was in a recent James Bond movie, I think, or maybe it was Mission Impossible, where the way you walk is a characteristic, a biometric characteristic. We call those soft biometrics, and there's a couple more examples, like your electroencephalogram, your brain waves, and your electrocardiogram, your heart rate, are other characteristics that are used to identify oneself. And then there's two slides here that identify those characteristics that help us define which biometric is best suited for a specific application. How universal is the biometric? I was half joking with somebody from a connected automotive or connected car. We're asking, how do we recognize the driver of the vehicle? Well, Tokyo University did a butt biometrics study. It's in terms of the way to collect information about the driver, and so how easy is it to collect? That you had to add a sensor on the seat. Collectability in terms of DNA, well, maybe it's easy as doing a cheek swab, but you wouldn't want to do that at a border crossing, right? How universal is it? Pretty much most of the major biometrics, face, finger, and iris, everybody has, or most everybody has face, fingers, and iris, maybe not all 10 fingers. And the stability of biometrics, for example, is aging affects our biometrics. When you get older, even your fingerprints, you lose lubrication in your fingers, and what we're taking impressions of are friction ridges, and they become dry and brittle over time. Your face changes when. Again, in border applications, if you're under 16, you typically have to get your passport renewed every 5 years instead of every 10 years because your face ages, so it's less stable. Then the other, I won't go through all these, but acceptability. So some populations don't like touching fingerprint sensors for two primary reasons. One, they feel it's a criminal type of application where you're collecting fingerprints, and two, there's fear of health implications of touching a sensor that 5,000 other people have already touched, right? So there's that acceptability, and of course, cost is a big factor. Iris is one of the more accurate modalities, but iris sensors have been traditionally 10 times more expensive than finger, and fingerprint sensors have been typically more expensive than the little webcam that's in all of our laptops or in most of our smartphones. And of course, fingerprint, especially with the introduction in the iPhone 5S, fingerprint sensors have been coming down in costs a lot as well. And then, of course, accuracy. Again, the core biometrics, face, finger, and iris are highly accurate. Gait recognition or ear recognition is certainly less accurate because there's typically less entropy, there's less information in those biometrics. Other, what we call soft biometrics, like the electrocardiogram, there's some devices like wristbands that connect to your phone, typically for fitness applications, but it's also for security applications. You could log into your phone, and as long as your heart rate is recognized within the range of your phone, you could stay logged into that device. So for continuous authentication, for example. In the larger sense, in one of the themes was security. Most security practices talk about three-factor authentication as being very secure, and those three factors are typically something you have, like an ID card, something like a password, and then something you are, like your biometrics. So for three-factor authentication, you typically have a smart card that you maybe plug into your computer. You have to put in a PIN and maybe face recognition. But we go a bit farther and say something you do, that's the behavioral characteristics again, and it could be keystroke dynamics, which we didn't talk about. So once you're authenticated into your laptop, if you move away, you could stay continuously logged in just based on the way you move your mouse or the way you interact with your keyboard. And then the context that we're working in, and we see this a lot in banking applications, especially again with smartphones, is where you're doing your financial transaction. So if you're normally in Helsinki, and all of a sudden you're on your device, something you have, it's your face, or we think it's your face. It might be a picture of your face, but now you're in whatever Mexico City. Well, maybe that would flag some banking app to ask for yet another factor of authentication. So ultimately, this picture is just about all the potential use cases to make your life easier. Well, how do we know this is who they say they are? How do we get rid of username and passwords in banking apps or just whatever apps? And how do we make things more secured so you don't have to enter PINs and make border crossings more efficient? These are the typical business drivers, which we kind of just talked about. So one of the technologies that we briefly mentioned was the introduction on smartphones of biometric authentications. And as soon as, within 24 hours of the 5S coming out, computer hackers in Germany said, well, we already spoofed the iPhone. It's not secure. What does that mean, right? Is a fingerprint sensor on a device or face recognition with the camera, or some, especially Korean phones now have iris capability. Is it more secure than no PIN or a PIN of 1, 2, 3, 4? So yeah, you hacked it, but you need a couple things, right? You need to get a latent fingerprint, and you need the person's phone. As soon as I lose my phone, I'm going to call and have it bricked, right? So there was a lot of hype around, the fingerprint sensor was spoofed. It's a known vulnerability, and there's ways to deal with it, including things like using another factor of authentication. This icon is, so the Fast Identity Online, or FIDO, is about not releasing biometrics from the smartphone. So how do we make it a friendly environment that's also secure? Well, if you're collecting a face, you're doing a selfie, and sending it back to mothership to do a facial verification, well, now you have the risk of it getting intercepted, your biometric getting intercepted in flight or from a central server. As was talking about in the IoT discussion. Now you have all this stuff in a central server waiting, it's a target-rich environment waiting for somebody to breach it. Well, what Fast Identity Online is basically saying, don't let biometrics leave the device. Keep it in a secure element and only exchange keys. So once I authenticate on the device, the FIDO protocol says, I'm going to release a key to the relying party and just do a very temporal, very time-sensitive key exchange. This was the NIME band that I was mentioning that has the cardio signal to a local device. So apart from fitness applications, again, it could be used to identify this physiological trait of the holder. And then, to get rid of, to make a more pleasurable experience, when you call the help desk, let's say it's financial services, and you have to name your first pet and the first car you own, the first employer you have, or with speaker recognition, we've been able to enable a lot of call centers to make that experience more secure and more user-friendly by using speaker recognition. This, through Windows 10, there's now inherent into the OS the facial recognition component that's, again, in the secure element. The face does not have to go back to the server, and it gives you a continuous authentication capability as well, just using the webcam in your PC. So all this is showing that you don't have to, we can move away from username and passwords, we can move away from providing a lot of data to a third party to authenticate yourself. So here's just more examples. So this is in border control. These are a series of the automated border control, or e-gates, electronic gates that actually Accenture, I think these are in Gatwick, if I'm not mistaken, that Accenture was part of. And the use case there is all of our e-passports have photos in them, and the use case is you place your e-passport on a passport reader. The photo is read from the e-passport. It's compared against a live face, so this is both a user prompt, a display, and a camera in here. So it's taking a live face, compared against the face in the e-passport. It'll do that biometric verification. It's also looking at the other part of the e-passport are all the certificates, the electronic certificates that are in place to make sure that it's a valid passport. So once it's determined that it's a valid passport, that you match it and you're not on a watch list, the gate's open. That typically takes 15 seconds. This is not an automated gate, but this is Accenture provided the back end for US Visit, which we're showing the front end here because it's the back end picture is just going to be a data center. But biometrics are collected by all third country nationals if you ever visited the US. The first time you enter, they'll take 10 prints. Typically on subsequent encounters, it's only 4, and all that goes into the US Visit database. This is another example of something we're working on. I think it's been abstracted. With one of our financial services clients, a biometric payment card. So right now, again, moving away from PINs, right now in Europe, well, most of the world except for the US, the banking cards are chip and pin, right? And so you have to either swipe your card or plug your card in and enter a PIN. In the US, it's chip and signature. But here, what we're working with a bank, you'll see that you can kind of see there's a fingerprint sensor on this card. So now it's chip and biometric. So you could biometrically authenticate to this card, giving it more security and more friendly use case because now you don't have to remember your PIN. And this is just showing, this is for Syrian refugees in Jordan. The Jordanians are offering assistance to through UNHCR to refugees, and you enroll in UNHCR and provide your iris biometric. The Jordanians allocate X number of dollars per refugee, and then they could go to an ATM using their iris, this is an iris sensor, and withdraw funds based on that. And what it's doing by adding the biometric component is making it easier to get access to money and making it more secure that only this individual could get those funds, and you can't exchange it or sell it for illicit or illegal activities. So then I moved, because this is it's supposed to be a more technical discussion. Okay, what is Accenture providing to enable this? So our unique identity service platform is what we developed over years of providing unique identity solutions to, in the past, mostly governments, but now financial institutions, and we actually have educational testing services, which is CMT, in Accenture speak now, and resources. So we've done some projects where for resources where creating identity cards, basically, biometric identity cards. This is just an application map. We don't have to go through all this, but the presentations can be made available. I just want to, okay, so that was the back end. So front end, we saw some of these use cases, but I just wanted to point out that not only were we doing the back end services, but for example, for UNHCR, we've created the enrollment capability as well to enroll face, finger, and iris at refugee camps. And we have, this is showing some of the configuration and monitoring capability. We'll get into this separately. The identity management. So biometrics are still probabilistic. In other words, there's a measurable error rate with biometrics. So let's say in India, we're enrolling 1.2 billion residents of India. When you enroll subject number 500,000,003 or whatever, you'll search the gallery, and maybe it'll say it hit on somebody else. So through this identity management console, we'll be able to have illustrate to the client what identity or identities maybe we hit against, and allow them to adjudicate that case, and either say, yes, this is the same person, and link the identities, or that it's not the same person. This is just a quick, and I realized after this that I missed two of the sponsors out here. I don't have Couchbase on here. We moved from a relational Oracle, typically data structure, to a NoSQL, specifically Couchbase, and we'll go into production with MasterCard and with educational testing services, in both cases using Couchbase, both cases using Amazon Web Services or Accenture Cloud Platform on AWS. At a very high level, this is basically our unique identity service platform in terms of the identity services that we offer. So that other picture with a lot of the underlying application elements is rolled up into what do? We allow people to pre-enroll and enroll. So pre-enrollment is, let's say it's a financial services that online you say, I want to open up an account. So you can pre-enroll in using one of our identity services, our pre-enroll service. Then let's say you come into the branch and they require finger and face. So then you can complete your enrollment, and then you could do these biometric-based identity services. And we won't go through all these, but for example, a verify is kind of like what I explained in the eGate situation. I'm doing a one-to-one of my claimed identity, my face, against the face of my passport, as opposed to this one-to-N. like I said in the example with India, where I want a unique identifier, I claim to be Dan, and I'm going to search against all the other identities in that huge database. So that's what an identify command is. We're not particular on which modality. We could plug in different vendors. It could be multiple fingerprint vendors, which we've done. For UNHCR, we're using 2 fingerprint vendors plus 1 face and 1 voice. And that allows us to get more accuracy. Or it also, especially with refugees, they might have poor fingerprints. So you revert to iris images to get a more accurate answer to who's the identity. This is just a quick slide, some of the unique identity efforts that we've done. We talked about some of these already. Yeah, so TSA, this was, I think I still, yeah. So this is a biometric smart card. Here it is, my TWIC card, the Transportation Worker Identity Credential, where we enroll and ultimately provision a secure biometric-based card so that a transportation worker that's seeking access to, I don't know, like a seaport, they'll go in, they didn't want to remember a PIN, so it has a mag stripe. So they swipe their card on a card reader. It has a fingerprint, 2 fingerprint templates in the card. So you swipe it, it reads it contactlessly, and then you put your finger on the reader, and it allows you entrance into the port. So that was, it's a huge Oracle Siebel case management with a lot of business rules around who can be provisioned this identity card. It's a $50 million program. So, 1 card, $50 million bucks. This is UNHCR. I just wanted to share with you what this looked like. So this is the face finger iris capture, but everything in this refugee camp had to be shipped in, including power, including the building itself, including the comms. And this is our lead guy from Sophia Tech Lab, formerly Tech Labs, now Emerging Tech, Tomas, and it's still in production. We've enrolled about 500,000 refugees, and it's still expanding. This one was the facial recognition, face in the crowd, as it's called. Just looking at time here real quick. Okay. So this, the use case here is, in terms of security, we might have a watch list of, let's say in a retail like Westfield, we did this pilot for Westfield. They might have some habitual theft problems where you're caught, shoplifting, and you get enrolled into their no shop list. And then as people come in, you'd be identified as one of those known shoplifters. It could be again, going back to Max's IoT world, it could be you don't want a magic band. You want to be identified to access a park or access a facility just based on your face. So the same use case, but now the database is the enrolled population, the good population. So anybody that's identified is allowed through. Anybody that shows up as not on the access list would be barred from getting in. We see this more for the negative case, for surveillance, for policing, that there's a watch list of known bad actors that they're trying to detect. Our video analytics folks take it beyond just facial recognition, and I think Jarkko talked about this a little bit in terms of there's other things that can be detected with our video analytics component, like behavior or accessing. So behavior, let me finish that thought. So it could be just people, you could detect fighting, you could detect crowding. You could detect, without doing a facial recognition, you could detect those type of things. You could detect luggage that's left behind. You could detect accessing restricted areas. As you could see here, there's this is for Westfield, where there's just cameras placed throughout. We did a pilot that's still going in Singapore, where not only you're looking for watch list folks, but what if any person went into this area that was restricted access? You could be alerted for that. This video is taking that face in the crowd and putting it on a drone, because drones are cool, so why wouldn't you, right? And this is our team in Bratislava, and some of them are enrolled in the database, and so the use case here is where, and this was early on, they still didn't get their pilot's license, I think. They're going to look at people in the crowd, and what we'll see is, down here is, as we detect a face, it'll show up here. As the face is detected and it's enrolled, it'll show up here with a name, or it'll show up here as we saw a human face, but they're not enrolled. So this would be that case where we've detected someone who's not enrolled, which in law enforcement would be good, because they're not enrolled, they're not on a watch list. And I think, so in this case, Emil was found, and here's his enrolled photo. In the policing case, that could have been a watch list. And we say, oh yeah, this guy Emil, we've been looking for him, and there he is. One of the things we were doing here, and we'll switch scenes in a second, is we were stressing out the facial recognition, because you could see it's in the shade. And it makes it more difficult for facial recognition to be accurate. And we're going to switch scenes in a sec to a more well-lit, and we'll get, a bit more. Yeah, and there's the team. Transition. Yeah, I can't really control it here, but it should be moving. There we go. But that's the use case here. So we actually have working with our patent attorneys, we have a patent pending on this. The method claims are fairly straightforward, but the application that we were going for is for land borders, especially here in Finland and next door in Estonia, where it's cold, and border guards have to inspect cars and their occupants coming across the border. What if we could put remote cameras or potentially drones that they could move around a vehicle in remote areas and peer into windows of cars and recognize the folks that are in there. So there you go. So we'll just move along. Then another thing that we're doing is applying the biometric capabilities in a mobile app. We call it MEVIS because it's mobile enrollment, verification, and identification. And in this case, the iPhone has a jacket in order to get a fingerprint, 2 fingerprints in this case, and iris. So a normal iPhone, we're getting face and voice. And we actually have, and I have the app on my phone, just using the native camera, you can collect fingerprint images with enough quality that you could do matching. Not as good quality as this device, but it'll still allow you to do a certain amount of biometric verification. So I wanted to include this example of our unique identity service platform as implemented in Finland here at the Port of Helsinki for a Smart Borders pilot. Smart Borders is Europe's answer to how do we manage third country nationals coming in and out of Schengen to determine overstays, basically. That's their primary objective, determine overstays. So as a third country national, I'm allowed to be in Schengen for a maximum of 90 days in any 180-day period. So when I came to Schengen, I transited through Munich. So what the law says today is the inspector in Munich has to look in my passport book, which has a lot of stamps in it, and determine in the last 180 days, has Dan been in Schengen for more than 90 days? There's no way that they could do that without spending an hour or two, in my case, looking through my passport. So they say we need an entry-exit system. It is what EU said. So we built a simulator for that. And we worked with the Finnish border guard, installed it here, and now when you do a passport swipe, as they call it, passport read on entry, we have in the system the date they came in. When they exit, we could determine the amount of stay and report that. So that's what we built. It interfaces with the Finnish border guard server, and the e-gates were developed by our partners at VisionBox. And next slide is a picture of those 3 e-gates, which are still there at the Port of Helsinki, with 2 of them were modified, one with a single fingerprint sensor and one with a 4-print sensor, kind of like the one you saw with the border guard from U.S. Visit. And the whole idea here was to determine not just that we could calculate overstays, but what's the impact going to be if we had to collect 1 finger, 2 fingers, 4 fingers, or 8 fingers in an e-gate. So that's what we did here. The services we offered, which we kind of discussed in the Unique Identity Service platform, is the identify and verify service, but also a status. In other words, is this person already enrolled in the entry-exit system? A few other things, and then ultimately the reports we reported on, ultimately what they wanted to see is overstays, but we also wanted to report on the quality of the biometrics captured, how long it took to go through that process, and, I thought we had the overstays. I guess I didn't put that report on here. Okay. But the average time, much like I was saying in Gatwick, the average time was, that's for fingerprint. The average total time was 15 seconds through here. But some of the outliers are just, huge. Then the whole idea of the fingerprints, we talked about the iPhone spoof. Any biometric has a vulnerability. Any system has a vulnerability. So some of the ones that we see, like in Visit, are where criminals know that they'll be, if they're fingerprinted, they'll be recognized. So they pay, in this case, a doctor $10,000 to remove their fingerprints. In this case, a guy coming across the southern border of the U.S. Paid a doctor to take his friction ridges from his feet and put them on his hand. And so when he came in limping into the inspection, the port of entry, they knew something was up, and as soon as they looked at his hands, they could see that he was trying to not be recognized. I think this one was an acid burn. But here's the gummy finger. So when you lift a fingerprint image, like from a glass or from the drinking glass or on an iPhone in that Chaos Computer Club example, you create typically a metal etching of it, and you pour some sort of gelatin or glue into that. Now with 3D printers, you could take an image and using Photoshop, create a depiction of that fingerprint image, then use its rendering to create a 3D profile, and then print it on a 3D printer to get the mold, and then again you pour the glue or whatever, or latex into that mold. For iris, you get these overlays. For face, you could create a mask, or really rudimentary. You hold up a flat picture. Now there's ways to deal with all those type of attacks, and we created a point of view on that. So just like viruses and other software attacks, you have the same sort of attack remediation with biometric vulnerabilities. Some of the other challenges are privacy related. Facebook being the one of the largest repositories of face biometrics, there's been a lot of pushback on, as you can see, some of the lawsuits about how Facebook uses some of those images. Some of the challenges are, we see retailers now using facial recognition or just facial processing to determine and market to different people. So from Minority Report, which was 10, 15 years ago now, they already predicted what this is a recent report from the UK, from CSC actually, about how retailers are basically doing what Minority Report predicted. And we were talking out in the hall about age prediction. I don't know who we were talking about, but this is from one facial recognition vendor. They're getting, you could typically get gender, age, and ethnicity by doing some of the face characteristic recognition. But you could see other things. Are they wearing glasses or not? Are they smiling? And so you could start getting things like from smiling and expression detection as well. Are they happy shoppers? Are they, are they angry? Here you get some other challenges, are perception. So I'm from New York originally, and this is one of our two senators, Chuck Schumer, who probably saw Demolition Man one too many times, and he actually said, you could always change the iris of your eye. Okay, so again, some of the challenges are there's some misperceptions about what you can and can't do with biometrics. So, this one is, okay, so what's next? We're seeing, I just showed a couple graphs here. So biometric smartphones are just, going bonkers here in terms of not just sales, but use cases of apps that are using those biometrics. Financial services are still a little bit hesitant. There's pilots going on every day, and we're involved in some of them. Before it to become mainstream, I think, there's going to have to be a bit more in terms of security and privacy. For low value and for account access and low value transactions, we're seeing it more and more. For larger transactions, I think there's more to follow. And then, of course, the resulting revenue from that. And I think, this was just the market segment in terms of which modality. Fingerprints is still huge, and I think part of that is, again, because of the iPhone. But we could see face is probably going to take up a bit more as that gets a bit more accurate, and voice, I think, is going to be as well. But that's that chart, and that's, I think we're still, I think we're still pretty good here. So questions and answers, yeah?
Yes, thank you, Dan. So now we have time for questions or comments, and please just raise your hand if you have one, and I will bring you the microphone. I'll give you a warm-up question. You actually mentioned that also biometrics are used for other than human beings, so I guess it's animals then. Could you give some examples on where are these taken and for what use?
Yeah, so, there's a couple use cases that I'm familiar with. So one is for cattle. There's RF tagging for some animals, in this case the livestock, get RF tags in like ears, but sometimes those are removed, and you could use nose prints, basically, are used for identifying cattle. And same thing with pets. Some pets are chipped, but not all pets are chipped. In other words, RF tag. And they could use paw prints and nose prints for identifying pets. So it's not a huge field, but it's been done, yeah.
Okay, there's a question.
Well, actually, I have two questions. The first is, what would What would be your bet for a winning combination in web authentication? What comes to biometrics, and second is how do the centralized authentication service brokers? What is their tendency where they're moving with the biometrics, like Google and Facebook and so on?
Yeah, so web is basically online, right? So I think because most laptops, tablets have face and voice, basically acquisition devices, in other words, a webcam and a microphone. I think those are the two biggest ones. And that educational testing services client are using those in particular because it's native to most laptops. And that's their use case as well. Now, in that case, we are, because it's a closed environment, we are collecting the face and voice samples and sending them to the back end, which was the other half of your question. And what we're providing to ETS, the Educational Testing Services, is a transaction-based, as a service way to biometrically authenticate. I think that's where that's going, as a service. And we're seeing more and more of those where you don't have to set up that infrastructure, you don't have to manage that infrastructure, you just send a biometric sample and say, please verify this, or please see if this person's in the database already. Now, the I guess concerns there are the data privacy, data protection. One of the ways you mitigate that is disassociate the biometric identifiers from the demographic information, the name, address, telephone number. You keep those separate, and you just have a link, some sort of primary key to that identity. And there's other ways to secure it, but again, what we've seen with especially with FIDO, Fast Identity Online, is moving away from that central repository for the general use case. There's still some specific, especially government cases, where you want to keep biometrics in a central repository, but secure.